Okay, we are moving on to the vertex forms of quadratics. You'll work a lot more with this kind of stuff in Algebra 2, so this is kind of the basics, but I won't lie to you, this is definitely a difficult lesson to do over a computer, but we are definitely going to do our best to do this, but I'm going to use Desmos to kind of visually show you what's going on. So let's first look at this warm-up. It is a state question, and basically what they're saying is that you have a landscape planting so many trees, okay? And with those 15 trees he's planted, it shows the height of all of them. And you're going to show a frequency, so how often it happens. So basically what I'm saying is from 0 to 1, how many times it happens. Well, if you look here, there's nothing. And then from 1 to 2, there's nothing. But from 2 to 3, still nothing. So our first numbers are 3.1, 3.2, all of that. So from 3 to 4, you're asking between 3.0 to 3.9, how many trees are happening. So that's 1, 2, 3, 4 trees. So we're going to go up to the 4 and make a box. And this is not going to be pretty, but okay. Then we're saying between 4 and 4.9, leading up to 5, how many are there? So there's 1, 2, 3 trees within that frequency. So we make another box. And again, this is ugly looking. And between 5 and 6, how many do we have? And it's 1, 2, 3, 4. So, wow, that's really crooked. And then from 6 to 7, we have 1 and 2 and 3. So we make this here. And between 7 and 8, we have 1. So that is our histogram, which is what it's called. It's basically just a frequency of how many things are happening. So there's that. Okay, so moving on to vertex form of a quadratic. So vertex form of a quadratic looks kind of goofy. And remember, I can either use y equals or f of x equals. So I'm going to use f of x because we need to get used to that. And I'm going to throw a bunch of letters out. So a, x minus h squared plus k. Okay, so the vertex is the h and the k. And I don't get why they use h and k, but that's just what we use in algebra here. Now notice that this h is positive and there's a negative sign in front of it. So like if we had x minus 2, that means the h would equal 2. But if we had like x plus 2, it actually means h equals negative 2. And the reason why is you'd have x minus negative 2, and a negative times a negative makes a positive. So keep that in mind, okay? And then the axis of symmetry is just going to be x equals, and it's always x equals, and it is h, because the axis of symmetry is always the x value of the vertex, okay? So I'm going to show you some examples, and then I'm going to show you some of them on Desmos, and then we're going to stop, and I'm going to do this page by page for the most part because there's a lot going on, okay? So by this form, whatever's in the parentheses and squared will give you the x value, and since it's adding, it's really the same thing as this, so that means that h is negative 4. So you have, the axis of symmetry is x equals negative 4. And then you take this as is. So since it's subtracting, it's negative 2. So I'm going to prove that to you. Okay. So, and we're going to go over a few other things with it. So this is originally what the graph would look like. This is the parent function is what it's called. F of x equals x squared is the parent function. I like to call it the basic white girl. It is literally as basic as you can get. Okay. So I know it's not as in to say common white girl or basic white girl, but just go with it. So this is the girl with her Starbucks in hand, all of that. Okay, so it's literally as basic as you can get. The more you add to it, the less basic it gets and more transformation happens. So the more you take away from the basic white girl, the more transformations are happening. So this is the original function. This blue function is what we just graphed. So let's just prove it. Negative 4, negative 2, right there is the vertex. Black point was on it. X equals negative 4. It cuts this graph right in half, and again, vertex is there. So I'm going to ask a few questions off of this. What transformations are happening from this red graph to this blue graph? Okay, let's see if it lets me right here. I don't think it would. Okay, so what transformations are happening from here to here? Well, I'm hoping you notice that it moved over 4. So it went left 4. Now, if we go back to here, we said x equals -4. So that shows you that it's moving left 4. And then if you go back, sorry for the quick flip, it goes down 2. So this -2 is going down, making it go down, I want to write it here, down 2. So keep this in mind because we're going to be talking about transformations on the next video, but I'm just trying to lead up to it. Okay, so let's look at number 2. If there's nothing added or subtracted to it, think of it like +0. Okay, there's nothing there. You don't ever really write that because it's not correct, but think of it that way for the vertex. Okay, so we have x minus 3. Okay, the 3 is the h, because that's what the formula says. So our axis of symmetry is x equals 3. And since there's nothing added or subtracted, the k would equal 0. So that means the vertex is 3, 0. Now I didn't ask this on the last one. I'm going to ask it on 2 and then go back to 1. What does the negative in front of this do? Any ideas? What is the negative in front? Well, if you said it makes it open down, you're correct. So that negative in front makes it open down, and that's what we call reflecting. Okay? If you notice there's a positive in front of here, so this graph opens up. And I would like for you to write this in your notes, so that way you have something to reference back. So this negative makes it open down, and we call that reflecting. Okay, so let's look at this graph in Desmos. I already have it ready to go. So what did this graph do? Well, this is the graph we have. This is the original. What happened from here to here? Let me show that coordinate. Let me show that vertex. Okay, well, if you say it shifted to the right 3, you're correct. So the vertex was here and it shifted over 1, 2, 3. It did not move up or down, so there's no vertical shift up or down. But if you notice, this is opening up on the red and the green is opening down. So do you see how it reflected over this axis right here? Okay, so what I would like for you to write in your notes is that this right here meant that it moved right 3. It did not move up or down, and this negative meant it reflected. Okay, so just things to think about. Okay, on number 3, I would like you to figure out the axis of symmetry, or try to, and the vertex on your own. If you get stuck, obviously restart the video. But let's see what you can do. This x squared might throw you off. So I want you to find the x value, the y value, and which way does it open? Does it open up or does it open down? All right, go ahead and pause the video now. All right, now that you come back to this video, let's kind of figure this out. Now, in this rule, it says x minus a value. Well, there's nothing being subtracted in these parentheses, and there's no parentheses. So if that's the case, you can actually think of it like this. We just don't write it this way, okay? And you can write that in your notes in your daily practice to help you, but I would like for you to recognize if it just says x squared, that means there was nothing moving left and right. So didn't shift left or right, and that will make more sense as we go through this. So that means x equals 0. Okay, what is this 3 added on? Well, that's the k, and that is the y value in the vertex. So we figured out x equals 0 for the vertex, y equals 3 for the vertex, and because there's that negative, I'm going to highlight it in yellow just like I did on the other one. What does that mean? Well, it means it's going to open down. Okay, it's going to open down because that negative makes it reflect. So let's go over the transformations. Again, just looking kind of forward to the next video. So we have this right here. Okay, the purple line. Do you notice how it didn't move left or right? This vertex is at 0 originally, and this vertex x value is at 0 too, right? It did shift up 3, and that's what we said it would do with the 3, because the vertex is now at 0, 3. And this is opening down instead of the red one where it's opening up, so it reflected. So the 3 transformations that occurred was that on this graph. Transformations. I won't put negative. It shifted up 3, and it reflected. All right, that's the end of the first video. Please move on to the next one. Upper left hand corner will link you to the next video. Bye.